hello. Question number 2. Let's do this. Okay, remember, you need to have already tried this. Compare it with the answer key, and then watch the video. If you read the problem and went, well, I don't know how to do that, I'll just watch the video. Pause the video. Go try it. Okay, you know what 6 kilometers is. You know what east is. Try something. Probably it'll be wrong, but you'll try. They've done studies. Your brain remembers stuff better if you try it and you're wrong, and then you learn the right answer. I also wish we could just learn things by watching videos of other people do it. I would be really good at basketball by now if that was true. Yep, I'd be really good at ice skating by now if that was true. Watch a lot of videos, then you magically get good at it. That's not how it works though. You gotta do it yourself. Okay, so let me... Okay, let's try this. Number 2. We've got a vector, another vector. We want to add them up and see where we're at. Let's do this. So vector A is 6 kilometers and due east. So probably it looks like that. Done. Vector B, it is 5 kilometers and it is 30 degrees west of south. West of south, what does that mean? Never eat soggy waffles? Or never eat slimy worms? Or whatever. West of south. So we start at south and then we go a little bit west. Okay, so we're at this angle. It's got a magnitude of 5 and it's 30. I'm trying to do a dotted line on my thingy. That angle right there, that's the 30. It's 30 degrees west of south. If it was straight up and down south, it'd be right there. But since we're west of south, we're kinked a little bit. Okay, so that is the y component. This is the x component. Okay, so it is 5, and that is a nice whole number, but we can't add it to the 6 because it's they're not lined up. So we have to split that 5 into its components. The way we do that is with a triangle. Okay, and we're gonna do some trig. We're gonna do sol, ka, toa. We will rarely use the toa. It's really just sol and ka. Okay, so I like sine, so I'm gonna use that one first. So sine theta, I don't normally draw the parentheses, but for you I'll do it. Sine theta equals opposite over hypotenuse. So the sine of that theta which is 30 degrees, is opposite, which is x, over the hypotenuse, which is 5. So 5 times the sine of theta equals x. Your teacher probably, instead of putting x, they just automatically put 5 sine theta, and here they'll put 5 cosine theta, because they do all this in their head, okay? I can't do it in my head either. You know what? And I am a very successful physics person. So if you have to write it down every time, no shame. No shame. Fastest does not mean smartest. You can take your time and write it down. Okay, so if you do like being fast and you want to be fancy, you can remember from unit circle that sine of 30 is a half. Okay, so if sine of 30 is 0.5, so 5 times a half, that is 2.5. If you don't remember that, I'm 50-50 on if I remember that. You can just punch in your calculator. It doesn't cost extra to use the calculator. So you can go sine 30. Make sure you're in degrees, not radians. Hit enter. Boop. It's 0.5. And then you go, oh yeah, could have skipped that step. Whatever. Multiply that by 5. It is 2.5. Awesome. Okay, so we got 2.5 for our x over here. Now I just need the y. So you have a couple choices. You can either use the cosine, because that one was sine, so this one has to be cosine. Or you can Pythagore it. You can go, well, a squared plus b squared equals c squared. I have a and b. Let me use c. All right, whichever you want. I'm just going to do cosine because I'm set up for it. But if you want to use Pythagorean theorem, you can do that too. Adjacent over hypotenuse. So the cosine of 30, it's not a whole number. It's root 2 over 2. You don't have to know that. I'm a dork, so I know that. The adjacent is y. Adjacent means next to it. So adjacent, it's adjacent to that theta, so that's the y. The hypotenuse is 5. Oh, because we're talking this is our right angle here. That's where that's coming from. Okay, so 5 times the cosine of 30 equals our y component. So the cosine of 30 is like 0.866. Yeah, times 5. That's 4.33. Okay, so I need to move my face so I have room to write hello. Okay, so we went to the right 6, and then we went to the left 2.5, and then we went down 4.33. Because these are vectors, that means it doesn't matter what order we do them. Okay, so I'm going to pretend we went right, then left, and figure out, like, where are we now? Okay, we went right 6, left 2.5. How far are we from where we started? Well, whatever 6 minus 2.5 is. 3.5, I think. Okay, so that bit, that's 3.5. And that's 3.5 to the right, okay? And then 4.33 down. So we went to the right, 3.5, down, 4.33. These are also right angles. I'm going to click on this. I hope I don't mess something up. It's blinking at me. Okay, I hope that worked. Okay. And we're wondering, well, how far are we from where we started? Actually, no, we're wondering the angle, right? What is the direction? Okay, so we need to find this angle. So we know that's 3.5. We know this is a right angle because like over and down, those are right angles to each other. That's why we split that 5 into like its x and y components. Okay, that's a right angle. And we know that this length is 4.33. Oh, a butterfly's on the window. Okay, 4.33. So we want the angle. Do we get to use tangent? I think we do. Okay, so tangent of theta is opposite over adjacent. If you're like, I don't like tangent, it makes me uncomfortable. You don't have to. You can use Pythagorean to find the hypotenuse, then use sine or cosine. That's an extra step, and I am all about skipping those. Okay, so the tangent of theta is opposite, which is 4.33, over adjacent, which is 3.5. Don't type that in your calculator yet. The question didn't ask you, what's the tangent of the direction? They said, what's the direction? So you have to untangent both sides. Okay, so you have to do tan -1, tan to the -1. I think that's called inverse tan of tan theta equals tan to the -1 of 4.33 over 3.5. Mandy, are those 3s? Maybe. We don't know. Okay, so you have to, whatever you do on one side, you have to do the other. Okay, so the untangent of the tangent of theta, those cancel out. That's just theta. That's why we did that. We want to get the theta by itself. Just like if you have like, you get it down to like, I don't know, like x squared equals nonsense. You have to take the square root of both sides. That's kind of what we're doing. We're taking the square root of both sides or multiply both sides by 5 but what we're doing is we're taking we're undoing tangent on both sides. On your calculator, the way you do that is you hit second tan. This is like a mirror image, so whatever that is on your calculator. Don't take the tangent, take the untangent. So tan to the -1, and don't type tangent and then go like to the -1. That won't work. You need to, if you can't find the inverse tangent on your calculator, Google it. Like Google like TI-84 plus inverse tan, and it'll like tell you how to do it. But probably it's just second tangent. Okay, so second tan, 4.33 divided by 3.5. I got like 50-ish. Okay, so 50-ish degrees. Okay. I think the answer choice is, yeah, only one of them's 50-ish. Now be really careful with the direction. South of east. So we'll never eat slimy worms. East is over here. I'm not going slow for your benefit. This is how long this takes me. So that's east, and going south of east does take us that way. How far south of east? 50-ish degrees. Okay, yeah, I'm feeling pretty solid that A is the right answer. Okay. You might think, oh, why did we get 50 when the real answer choice is 51? Because we like rounded a lot in here. I think that wasn't 4.33. It was 4.33 stuff that I just didn't save. If you're like, no, I want to keep all my decimals, you can store it as X and then like use it later. It's multiple choice, and the answer choices are really far apart, which is why I rounded internally. And that is Okay. Okay, so that is how you do that one. If you did not nail this the first time, try again. Start fresh, start blank, start without the video. Just you and the problem and your pencil and your calculator. Do it again, okay? And then do it again tomorrow, and then do it again in a week. Until, like, you gotta practice, okay? You gotta practice, okay? I'll see you over at question 3.